Friends, welcome to the class. Today we'll discuss about surface area and volume. In earlier classes, we learned about the surface area and volume of solids like cube, cuboid, cylinder, cone, sphere, and hemisphere. In this chapter, we'll learn how to find the surface area and volume of combination of solid figures, that means conversion of solid from one shape to another, or a frustum of a cone. So before we get into this topic, let us first have a small recap of whatever we have learned. Let us have a small review of some important definitions, some formulas, and then we'll start the chapter. So let's start. Solid figures. The objects having definite shape, size, and occupies a fixed amount of space in 3 dimensions are called solid figures. For example, cubes, spheres, etc. Surface area. Surface area of a solid is the area of all its surface together. It is always measured in square unit. For example, a cube has 6 surfaces and each surface is of the form of a square. So the surface area of a cube is 6a square unit, where a square is the area of a square. Volume. Space occupied by an object or a solid body is called volume of that particular object. Volume is always measured in cube unit. For example, let us assume the cube has the length a unit. Volume of a cube is equal to the product of the area of the base and height of the cube. That means it is a square into a, or it equals to a cube unit. So important formulae. Cuboid. A cuboid is a solid figure having 6 rectangular faces. Let's draw the picture first. Let the length, breadth, and height of the cuboid is L, B, and H respectively. Then the total surface area, or in short we can write TSA, equals to 2 whole into LB plus BH plus HL square unit. Lateral surface area of the cube equals to 2 into L plus B whole into H square unit. Diagonal of the cuboid equals to square root of L square plus B square plus H square unit. And volume of the cuboid is L into B into H cube unit. Cube is a special kind of cuboid which has 6 equal square faces. Let's draw the picture. Let the set of the cube is a unit. Then the total surface area of the cube, or we can write TSA, equals to 6 into side square, or it is 6a square unit. Lateral surface area of the cube is 4 into side square, or it is 4a square unit. And diagonal of the cube is root 3 into a square unit. Sorry, root 3 unit. Root 3 is a square unit. And volume of the cube is a cube unit. Right circular cylinder. Cylinder is a solid figure obtained by revolving a rectangle, say ABCD, about its one side, say BC. Let's draw the picture. So let ABCD is a rectangle. So if we rotate that is taking BC as a center, if we rotate AD, then the solid that we get, that will be nothing but the cylinder. Let the radius of the right circular cylinder is R unit and its length be H unit. Then the curved surface area, or CSA, is circumference of the base into height. Curved surface area means this total surrounding area. The surrounding surface area is called curved surface area. It is 2 into pi RH square unit. Total surface area, or TSA, is curved surface area plus area of the two ends. It is 2 pi RH plus 2 pi R square, or 2 pi R into R plus H, because total surface area is this total curved surface area plus these two ends. That means the two ends of the circle. So it is 2 pi RH, 2 pi RH is the curved surface area plus 2 pi R square. It is 2 pi R into R plus H whole square unit. Volume of the cylinder is equals to area of the base into height, or it is pi R square into h cube unit. Right circular hollow cylinder. Let's draw the picture. Let capital R and small r are the units of the external and internal radii of the hollow cylinder respectively, and h is the units of the height. Then the curved surface area is nothing but curved surface area of the outer cylinder plus curved surface area of the inner cylinder. So it is 2 pi capital RH plus 2 pi RH, or it is 2 pi R 2 pi whole into capital R plus small r whole into h square unit. In the first case, this is a solid cylinder, but in the second case, this is a already, as the definition says, it's a hollow cylinder. So in this case, we have to, when we are going for finding a curved surface area, we have to find out the curved surface area of the outer cylinder plus that of the inner cylinder. Total surface area, or TSA, equal to curved surface area of the hollow cylinder plus area of both the ends. That means 2 pi r 2 pi whole into r capital R plus r whole into h plus 2 pi capital R square minus small r square. Or on simplifying, it is 2 pi capital R plus small r whole into h plus capital R minus small r square unit. Total outer surface area is 2 pi RH capital RH 2 pi capital RH plus 2 pi capital R square minus small r square unit. And volume of the hollow cylinder is volume of the outer cylinder minus volume of the inner cylinder, or it is pi capital R square h minus pi small r square h, or we can write it's pi capital R square minus small r square whole into h cube units. Sphere. A sphere is a solid generated by the revolution of a semicircular circle about its diameter. Let's draw the picture. This is a semicircle. So if we rotate it along its diameter, the object that is obtained, that is a sphere. Let the radius of the sphere be r, then the surface area of the sphere is 4 pi r square unit. Volume of the sphere is 4 by 3 pi r cube unit. Spherical shell. Let capital R and small r the outer and inner radii of the spherical shell. Then the volume of the hollow sphere is 4 by 3 pi capital R cube minus small r cube unit. Outer surface area is 4 pi r square unit. Hemisphere. A plane passing through a center cuts the sphere in two equal parts. Each part is called hemisphere. That means this is a complete square. We can take any part, either upper part or lower part, or let's say left part or right part. One part represent a hemisphere. Let's draw the picture. This picture is like this. That is one part of the sphere. Let radius of the hemisphere is r unit. Then curved surface area of the hemisphere, or CSA, is 2 pi r square unit. Total surface area of the hemisphere is total curved surface area of hemisphere plus area of one end, is 2 pi r square plus pi r square. This total surface area is surface area of this curved surface area plus this upper part. This upper part is nothing but a circle, and this one is 2 pi r square. It is 2 pi r square plus pi r square, which is equal to 3 pi r square. Why curved surface area of hemisphere is 2 pi r square? Because the curved surface area or surface area of the sphere is 4 pi r square, because it is complete one. When we are taking one half, so it is 4 pi r square by 2, or it is because of this then 2 pi r square. This 2 pi r square represent this half portion and plus this upper circle. So it is 2 pi r square plus pi r square, which is equals to 3 pi r square. Volume of the sphere, it is equals to 2 by 3 pi r cube unit. Friends, already you learned all these formulae in previous classes, but it is just a recap of this one. right circular cone. A right circular cone is a solid generated by revolution of a right angled triangle about one of its sides containing the right angle. Let's draw the picture. So let this is a right angle, this left part. So if we keeping this the vertical as a constant, if we rotate the triangle, then the object that is obtained, that is nothing but a cone. Let height of the right circular cone is h and radius is r unit, and slant height of the cone is L, or L is nothing but square root of r square plus h square unit. So curved surface area or CSA is pi r L square units. Total surface area of the cone or TSA is nothing but curved surface area plus area of the base, that is pi r L plus pi r square, or pi r whole into L plus r square unit. And volume of the cone is 1 by 3 pi r square h cube unit. Let's see some examples. A solid ball is exactly fitted inside a cubical box of side A. What is the volume of the remaining space inside the cubical box? Let's draw the picture first. So as it is clear in the picture, this is a cube and a spherical ball is fitted exactly inside the cubical box. Given that a solid ball is exactly fitted inside the cubical box of side A, so the diameter of the ball is equals to this side of the cuboid, or it is nothing but let the radius of the ball be r. So you can say 2r equals to a, because diameter is twice of radius. So 2r equals to a, or you can say r equals to a by 2. Now we know that the volume of the sphere is 4 by 3 r cube units. So this implies volume of the ball or volume of the sphere, it is 4 by 3 pi into a by 2 whole cube, or it is nothing but 1 by 6 pi a cube unit. Now we know that the volume of the cube of side A is a cube. So the volume of the remaining space inside the cubical box is equals to volume of the cubical box minus volume of the wall, or it is nothing but a cube minus pi a cube by 6, or you can write 6 a cube minus pi a cube whole divided by 6 cube unit. Or if you take a cube by 6 common, it is a cube by 6 whole into 6 minus pi cube unit is the answer. A tent is in the form of a shape of a right circular cylinder up to a height of 3 meter and a conical above it. The total height of the tent is 13.5 meter and radius of the base is 14 meter. Calculate the cost of painting the inner side of the tent and the rate ₹2 per meter square. Let's draw the picture first. So this is the tent up to 3 meter. It is of the form of a cylinder, and above it is a conical one. The total length or the total height, we can say total height is 13.5 meter, and this much is 3 meters. So you can see this upper part is 13.5 minus 3, which is nothing but 10.5 meter, and it is also given that radius of the base is 14 meter. So this one part is from the dotted line to this line is 14 meter. So given that the tent is of the form of a right circular cylinder and conical above it, the total height of the tent is 13.5 meter and height of the cylindrical area is 3 meter. Radius of the base is 14 meter. It is already given. So that means height of the conical area is 13.5 minus 3, which is 10.5 meter, and radius of both cylinder and cone, this is 14 meter. This is the common radius for this particular cylinder and also for this particular cone. Now painting will be done on the surface area of the tent. That means we have to find out the total surface area of the cone as well as the cylinder, both. The total surface area of the tent equal to curved surface area of the lower cylindrical part plus curved surface area of the upper cone. Sorry, not I said surface area, it's not surface area. We have to find out the curved surface area of the cone as well as that of the cylinder. So total surface area, or we can say that was the record area of the tent is 2 pi rh plus pi rl, or which is nothing but pi r into 2h plus l, or on putting the values it is 22 by 7 into 14 into 2.3 plus square root of 10.5 whole square plus 14 square, or it is nothing but 44 into 6, 44 whole into 6 plus 17.5, which is nothing but 1034 square unit. Now the cost of painting is rupees 2 per meter square. So the total cost is cost of painting at the rate 2 per meter square. So the total cost of painting is 1034 into 2, or it is 2068 rupees. Hence, the cost of painting the tent is rupees 2068 is the answer. A solid is composed of a cylinder with hemispherical ends. If the whole length of the solid is 104 cm and radius of each hemispherical ends is 7 cm, find the cost of polishing the surface at the rate rupees 2 per decimeter square. Let's draw the picture first. So this the solid, the end part of the solid constitute a cylinder with two hemispheres at both the ends, and the total height is 104 cm and the radius is 7 cm. Given that the whole length of the solid is 104 cm and the radius of each hemisphere is 7 cm, so the length of the cylindrical part is 104 minus 2 into 7, or it is 90 cm, because this height is 7 cm, this height is 7 cm, so 7 plus 7, 14. 104 minus 14, which is equals to 90 cm. So for the hemispherical portion, radius is 7 cm. For the cylindrical portion, radius is 7 cm and height is 90 cm. Your total surface area of the solid is 2 into curved surface area of the hemisphere plus curved surface area of the cylindrical part. 2 into curved surface area of the hemisphere, because this is one hemisphere, this is another hemisphere. So curved surface area of one hemisphere into 2, and plus total curved surface area of this middle cylindrical part. But it's 2 into 2 pi r is 2 pi r square plus 2 pi r h, or on putting the values, it is 2 into 22 by 7 into 7 square plus 2 into 22 by 7 into 7 into 90, or on solving we get it is 4576 centimeter square. Now the cost of polishing is rupees 2 per decimeter square. So the total cost of polishing is 4576 into 2 by 100. Why by 100? Because it is, we got it in the form of centimeter square. So if we convert it into decimeter square, we have to divide by 100. So it is 4576 into 2 whole divided by 100, or it is equals to 91.52. Hence, the total cost of polishing is rupees 91.52 is the answer. Neetu runs an industry in a set which is in the shape of a cuboid surmounted by a half cylinder. If the base of the set is of the forms 7 meter into 15 meter and height of the cuboid portion is 8 meter, find the volume of the air the set can hold. Further, the machinery in the set occupies a total space of 400 meter cube, and there are 15 workers, each of whom occupy about 0.08 meter cube space on average. Then find how much air in the set. Let's draw the picture. So here is the set. Given that the dimension of the cuboid is 7 meter into 15 meter into 8 meter. Radius of the semi-cylindrical surface is 7 by 2 and its height is 15 meter. Because this is the length, so for this semi-cylindrical part, we can say this 15 is the height. Here total width is 7 centimeters. So for this semi-cylindrical part, the radius will be 7 by 2. it is 7 by 2 meter. Now, volume of the seed equals to volume of the cuboid plus volume of the semi-cylindrical part, or it is nothing but LBH, because volume of the cuboid is L into B into H, plus 1 by 2 pi r square H, because total volume of the same cylinder is pi r square H. It is 1 by 2. It is semi-cylinder, so it is 1 by 2 of the volume of the total cylinder. So 1 by 2 pi r square H. Or on putting the values, we get it is 15 into 7 into 8 plus 1 by 2 into 22 by 7 into 7 by 2 into 7 by 2 into 15. Or it is nothing but 1128.75 meter cube. Now total space occupied by the machinery is 400 meter cube, and total space occupied by the workers, there are 15 number of workers and each occupy around 0.08 meter cube. So it is 15 into 0.08, or it is nothing but 1.2 meter cube. So the total volume of the year in the machinery and works present in the set is volume of the set minus space occupied by the machinery and the workers both, or it is 1128.75 minus 400 minus 1.2, that is 727.55 meter cube. Thus, the air present in the set is 727.55 meter cube is the answer. Friends, here is a few questions. We'll discuss more in the next classes. In the meantime, you keep on practicing more and more such questions. And in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, in solving your questions. So this was for today's class. Thank you.